Hi there, students of economics. This is teacher Shirley, and I'm here to take you forward with the topic produces behavior. So stay with me. Before we move on, let's spell out the contents of this lesson. We will be dealing with the law of variable proportions, which studies the response of output to a change in the variable factor. Secondly, we will deal with the product concepts, total product, average product, and marginal product. And thirdly, we will study the law of returns to scale, which studies the response of output to an increase in all factors in the long run. Let's begin. On the outset, I'd like you to imagine something. Consider that we have before us a workplace, and the following is being used. Perhaps this is a factory or an industrial unit. We have in this unit two machines, which is our fixed factor, and unskilled workers, which is our variable factor. Let's see what happens in this factory situation. We have two machines, which is the fixed factor, and what we are trying to study is what happens in the short run in this production process. How does output change as a result of changing the variable factor? And in this case, the variable factor is the unskilled labor. Suppose we carry out production with the two machines and this one unskilled labor. We derive an output of 3 units. In the next situation or next instance, we add one more laborer to the production process, and together these two produce an output of 7 units. Further on, another laborer is added, and together the 3 of them produce 12 units. In the production process, the employer probably feels he needs to step up production, so he introduces yet another unskilled labor, and together the 4 of them produce an output of 16 units. Then again, another unskilled laborer, the 5th one, is added to the process of production, and the 5 of them produce an output of 19 units. Further on, production is carried out with yet another unskilled laborer, and they together, the 6 of them, produce an output of 19 units. When the 7th unskilled laborer is added to the process of production, it is seen that the total product or total output decreases from 19 to 17 units. What we have just seen in the example that we took is put in the form of a table. We have 5 columns here. The first column is the number of units of the fixed factor. In this case, the fixed factor remains constant throughout, which is the 2 machines. In the second column, we show increasing amounts or units of the unskilled labor, which is the variable factor in this case. So you see the factor proportion is increasing. The total product of 1 unit of labor is shown here, which is 3 units. When 2 of them are employed, together they produce 7 units. When 3 are employed, together they produce an output of 12 units. When 4 are employed, they together produce a total product of 16 units. When 5 of them are introduced in the process of production, they all together produce an output of 19 units. When yet another unskilled labor is added to the process of production, together the 6 of them produce 19 units. And when the 7th unit of unskilled labor is added, they produce 17 units. So we see the total product after introduction of every additional unit of the unskilled labor. We have other columns here, which is marginal product and average product. Marginal product is nothing but the addition to the total product by use of an additional unit of the variable factor. For example, when 1 unit of variable factor is employed, the total product rises to 3 units. So the marginal product or the additional product is 3 units. From 1, when another unskilled laborer is used, the total product rises from 3 to 7. So we see an addition of 4 units. How did we get that? 7 minus 3 is 4. Then again, when another unskilled labor is employed, it rises from 7 to 12. So this rise in the total product is shown by marginal product, which is 5 units. We got that when we minused 7 from 12. So 12 minus 7 is 5. We can go on further with every additional unit of the labor. The total product goes on increasing by a certain amount. That amount is given by the marginal product. So 16 minus 12 is 4. 19 minus 16 is 3. 19 minus 19 is 0. And 17 minus 19 is negative 2. So we take the sign of the bigger number. So we see the marginal product is increasing initially, then it starts falling, it becomes 0, and then actually takes a negative value. Let's move on to the column average product. How do we find average product and what does it tell us? We find average product by dividing total product by the number of units of the unskilled labor or the variable factor. So 3 divided by 1 is 3. 7 divided by 2 is 3.5, and this tells us what each laborer contributes to production. See, on the average, per unit of production or per unit of the variable factor, the output is 3.5. That means if we have 2 laborers, each of them contributes to production by producing 3.5 units of the product. Similarly, 12 divided by 3 is 4, which means each of the 3 produces 4 units. Did you get that? Here again, 16 divided by 4 is 4, which means each of the 4 unskilled laborers produces 4 units. Then again, 19 divided by 5 is 3.8. That means each of the 5 contributes to production by way of producing 3.8, each of them. 19 divided by 6 is 3.16. 17 divided by 7 is 2.42. What we have seen in the example and the table can be generalized now in the form of a law, which means it could be applicable to all production processes in the short run. So let us state the law. As the proportion of one of the factors in the combination of factors increases, first the marginal and then the overall product will diminish. This is called the law of variable proportions, because by using every additional unit of the variable factor, the factor proportions between fixed and variable factor changes. We will see again with the help of the table how the marginal product first diminishes and then the total product or average product will diminish. Here are the assumptions to the law of variable proportions. First assumption, technology is assumed to be given and constant. The second assumption, the ratio in which the factors of production are combined can be changed. We saw in the table how the ratio of the combination of the factors is changed. So in the first instance, for example, we have 2, 1, then 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7. So the ratio in which the factors of production are combined were changed in our example. The third assumption, all units of the variable factors are equally efficient. That means each of the unskilled laborer that was employed was equally efficient. Let us now examine the same table but in view of the law of variable proportions. What does the law state? It states that as the proportion of one of the factors in a combination of factors increases, first the marginal and then the total product will diminish. We can clearly see if we compare these two columns of total product and marginal product, which one declined or decreased first. Is it marginal product or total product? As we see at the third unit of the variable factor, the marginal product is 5, total product is 12. At the fourth unit of the variable factor, marginal product falls from 5 to 4. but total product is increasing. So that means marginal product falls first. Then we see at the 6th unit, total product is 19, and when the next unit of the variable factor is employed, total product falls from 19 to 17. So we see total product falls later. Marginal product increases first, then starts falling. Later on, when marginal product is 0, total product starts falling, and that time marginal product becomes negative. Let us study the law of variable proportions with the help of a neat label diagram, as we are always asked, right? So here we see that total product, marginal product, and average product are taken on the y-axis, and the units of the variable factor or the unskilled laborer is taken on the x-axis. So you see we move from 1 to 2 to 3 to 4 to 5 to 6 to 7 units of the variable factor. Since we are drawing the total product curve, the average product curve, and the marginal product curve, we take the 3 of them on the y-axis. We see in the diagram there are 3 stages happening in this process of production in the short run. Well, let's see what happens in stage 1. Stage 1 is called the stage of increasing returns because throughout, when total product starts from 0 and right up till this point where marginal product is at its highest, total product is increasing at an increasing rate. So we call it the stage of increasing returns for that reason. Throughout this stage, we see that marginal product, which is shown with a green colored curve, is greater than average product. The stage starts when all of them are 0 and ends when marginal product is at its highest point. Because up till that point, total product is increasing at an increasing rate. Moving on to the second stage, which is called the stage of diminishing returns. Throughout this stage, total product increases at a decreasing rate. In this stage, marginal product cuts the average product curve from above. Then later after this, average product becomes greater than marginal product. It is in this second stage that average and marginal product are both seen to be decreasing because total product is increasing, however, at a decreasing rate. In the third stage, we see that total product is actually falling. This stage starts from when marginal product becomes 0. When total product decreases, marginal product becomes negative. For example, this point here represents when total product is 17, and this point represents when total product is 19. So 17 minus 19 is -2, and that -2 is plotted here. When we plot all the points that we see in the table against the variable units of the variable factor, we can join the points and we derive the total product curve, the marginal product curve, and the average product curve. So in the first column, we have the fixed factor. In the second column, we have the variable factor, right? So we plot the variable factor against the units of the total product and we get these points. When we join them, we get the total product curve. When we take the units of the variable factor and plot it against the units of marginal product, we get the green curve. When we join the points, we get the green curve, which is the marginal product curve. Similarly with average product, it is plotted with units of variable factor against units of the average product, and when those points are joined, we get the red colored curve, which is the average product curve. So here is explaining the 3 stages of the law of returns to scale. And the first stage is called the stage of increasing returns. In this stage, total product increases at an increasing rate up to the point where marginal product is at its highest. That is what I showed you when we were studying the diagram. Throughout the stage, marginal product is greater than average product, so that the marginal product curve cuts the average product curve at its maximum point in the second stage. Let's study the first stage with the help of the diagram. As you can see, it starts with 0. Total product is increasing at an increasing rate. Throughout this stage, we said that marginal product is greater than average product. It is only in the second stage that the marginal product cuts the average product curve at its highest point. Moving on to the second stage, which is called the stage of diminishing returns. In this stage, total product increases but at a decreasing rate, with the result that both average and marginal product decline. This stage starts from the point where MP is at its highest and continues to the point where MP equals to 0. At the end of the stage, total product is at its maximum and AP is greater than MP. Let's refer to the diagram to study stage 2. As we said, stage 2 starts when MP is at its maximum point and ends when MP is equal to 0. MP is equal to 0 when TP is at its highest, that is, total product is at its highest point. In the beginning of the stage, marginal product cuts the average product curve from above at the highest point of the average curve. Later on, after this, average product becomes greater than marginal product. However, both are on the decline because total product is increasing, however, at a decreasing rate. Let's explain the third stage, which is the stage of negative returns. The stage starts from the point where total product is at its highest point and MP is equal to 0. During this stage, total product decreases and marginal product becomes negative. This is because after a certain period, the production process becomes too crowded with a variable input and factor proportions become less suitable for production. You saw when 6 units of the variable factor were employed, the total product was 19. And then when another variable factor on skilled labor was added to the process and they became 7 units of the variable factor, we saw how total product actually fell from 19 to 17. Why? Because the production process becomes too crowded with a variable factor. And so the factor proportions becomes less suitable for production. Would anyone want that? No. So the producer will know where he has to stop when he is employing the variable factor, which is the unskilled laborer. While we were studying the law of variable proportions, we came across 3 concepts. The first being total product. What is total product? It is the total quantity of output produced by a firm using fixed and variable factors at a time at a place. It is the sum total of output of each unit of the variable factor used in the process of production. For example, along with the fixed factor, when 1 through 7 units of the variable factor are used, we get a resulting output of 3, 7, 12, 16, 19, 19 and 17. So the total quantity at each level produced by whichever number of unskilled laborer used in the process of production would give us the value of total product. The second concept is marginal product. It is defined as an increase or change or addition to the total product which takes place as a result of using another additional unit of the variable factor, other factors remaining constant. So we have a formula here, MPN equals to TPN minus TPN minus 1. Maybe MP at the 4th unit is equal to TP at the 4th unit of the variable factor minus total product at the 3rd unit of the variable factor. Say for example, total product at the 4th unit of the variable factor is 24 and total product at the 3rd unit of the variable factor is 18. So 24 minus 18 is 6. So we see the key word for us to remember here when we study a concept where there is a reference to marginal is increase, change or addition. And that takes place by using one more or an additional unit of the variable factor. Moving on to the third concept, which is average product. Average product is defined as per unit product of a variable factor of production, or it refers to physical output per unit of the variable factor used in the process of production. See, the key word here for us is per unit. So it tells us each unit of the variable factor, how much does each unit of the variable factor contribute to the process of production. It can be calculated by dividing the total product by the number of units of the variable factor used. It is calculated as follows. Average product equals to total product divided by L. L is the unit of the variable factor. So total product in this example is 12 units and divided by 3 units of the variable factor which is used at that level, and we get the answer as 4. 12 divided by 3 is 4, which tells us that each of these 3 laborers contributes to production by producing 4 units. Each of them produces on the average 4 units. Let us move on to the third part, where we are going to study about the law of returns to scale, which is applicable to the long run. What if fixed and variable factors are doubled or changed in the same proportion? Let's see what happens. Here's what happens in the long run when all the factors are doubled at each stage. So in the long run, we have long enough time to increase the scale of production. And when we increase the scale, we are changing both the variable and fixed factors in the same proportion. So initially, we begin like this. In the first instance, we have 2 units of labor, 5 units of capital, and together they produce 50 units of the output. Now let us begin. In the first stage, the inputs are doubled. Let's see what happens. 2 units of labor becomes 4 units of labor, 5 units of capital becomes 10 units of capital. We would expect that the output doubles because we have doubled the inputs. However, in the first stage of the law of returns to scale, we can see 50 is not become 100. It has become more than 100, which is 110. That means in the first stage, when the inputs are doubled, the output more than doubles, or there is a more than proportionate increase in output as a result of doubling the inputs. Let's see what happens in the second stage when the inputs are further doubled. So at every stage, we are doubling the inputs. 4 becomes 8 units of labor, 10 units of capital becomes 20 units of capital, and we expect that output will double, and that is exactly what happens. In the second stage, output just doubles. So 110 multiplied by 2 is 220. So we see that there is a proportionate increase in output when there is an increase in the inputs or doubling of the inputs. Let us see what happens in the third stage. The inputs are further doubled. 8 becomes 16 units of labor. 20 units of capital becomes 40 units of capital. And we would expect that the output would further double. If they had to double, 220 multiplied by 2 would be 440. However, we see that the output is not 440, which means the output has not doubled. It has less than doubled. If it had to double, it would be 440, right? But we see that it is 400, which is less than double. So in the third stage, when the inputs are doubled, the output less than doubles. So there is a less than proportionate increase in output in the third stage when the inputs are doubled. So we have studied the law of returns to scale with the help of an example. We see distinctly there are 3 stages in the example we just analyzed. The first stage, in which the output more than doubles, is called the stage of increasing returns to scale. In the second stage, we see that the output just doubles with an increase in the inputs in the same proportion, and so we call it the stage of constant returns to scale. The third stage is called the stage of decreasing returns to scale because the output less than doubles when the inputs are increased in the same proportion. Let's describe the first stage, called the stage of increasing returns to scale. In the first stage, when inputs are doubled, the increase in output is more than proportionate to an increase in input. That is, the output is more than double. The second stage, which is called the stage of constant returns to scale, when the inputs are doubled, the output increases in the same proportion in which the inputs are increased. That is, when labor and capital are doubled, output also increases by 2 times. So we see that there is an equally proportionate increase in output as a result of an increase in input by the same proportion. Stage 3 is called the stage of decreasing returns to scale. In this third stage, when inputs are doubled, increase in output is less than proportionate to the increase in input. That is, the output is less than double. We saw in the example how there is a less than proportionate rise in the output when the inputs are increased in the same proportion. Having studied the law of variable proportions and the law of returns to scale, let us now just revise some of the concepts we learned. We learned about total product. It is the total quantity of output produced by a firm using fixed and variable factors at a time, at a place. So you see, it is only in the short run where we divide factors as being fixed and variable factors. You saw in the law of returns to scale, we increased all the factors in the same proportion, so we didn't talk about factors being fixed and variable. So these 3 terms will be applicable to the short run. Let's move on to the second. Marginal product. It is an increase or change or addition to the total product which takes place as a result of using an additional unit of the variable factor, other factors remaining constant. So the keywords for you in marginal concept is increase, addition or change due to use of one more unit of the variable factor. Moving on to the third concept, average product. It is defined as per unit product of a variable factor of production. So the keyword here is per unit. So when we come across a concept wherein average is mentioned, then you will have the word per unit. So it is a per unit product of the variable factor. Today we have learned about the law of variable proportions, 3 product concepts, that is total product, marginal product and average product, and we learned about the law of returns to scale. Thank you, students of economics. We have come to the end of this teaching module. I would advise you to please study and revise all the concepts taught in this module. These concepts can be applied to the real life situation, especially in a branch of economics called managerial economics. And all this guides producers, firms, businesses, managers to take the right decisions in different time frames or time periods. We will learn how to apply all this knowledge later. Thank you, students.